Okay, so now let's talk about how do we apply, let's start with normal mapping. How do we apply a normal map onto an object? Okay, so let's say this is a cube onto which we want to apply normal mapping. And this is a normal map. First of all, what are the contents of a normal map? What does each pixel contain? So in a normal map, each pixel contains an RGB value. RGB value, this is in 0 to 55 range, okay, RGB. So how does it relate to normal? And as we know, normals are unit vectors. So the corresponding XYZ value of the normal is computed as follows. So let's say we first take the RGB value. Okay. Now we can compute the let's say XYZ value by dividing this RGB value with 255. Okay. So this result is then going to be in 0 to 1 range. XYZ is going to be 0 to 1. But as you know, normals can point in any direction. Okay, they can point in, so they can point in negative x, negative y. Okay, so they can point in different directions. So 0, 1 limits us. Okay, 0, 1 is not enough. So what we do is so let's call this XYZ prime. We subtract. To find the actual normal direction, we subtract from the XYZ prime this vector, okay, 0.5, 0.5, 0.5. So when we subtract this, the result is going to be in range minus 0.5 to plus 0.5. Okay, so now these are the XYZ values. So this almost represents our normal. Okay, so let's call this XYZ double prime. Now the actual normal is going to be computed by the normalization of this value. So the normal vector indicated at every point in the texture is going to be normalize XYZ double prime. Okay. So as you can imagine, when XYZ, each of them is in minus 0.5 to 0.5 range, it means that they can point, the normal can point in all possible directions. Okay. But we know that the normal must also be a unit vector. Okay, it can point in every direction, but its length must be a unit vector. So to compute the normal from the normal map, the last thing that we must do is to normalize. Okay, so this is how we convert the RGB value stored in a texture into its corresponding geometric normal.